So in reading through the docs, it seemed like there's a focus on like these security primitives, like looking at the bot protection feature as a whole. It's really just kind of like a composition of the other primitives that are found in Arcjet. So are there any other primitives that you want to add that'll unlock some like new security things?
Right. So we've come across it with this idea of primitives that you can compose. We provide what we call a product that uses multiple primitives configured in our recommended way. So sign up form protection uses bot protection, rate limiting, and email verification, and you can use that. Just drop in the code and use it in one go, or you can use them individually and configure them directly. And the idea behind this was that something that I'd seen from console.dev is that developers tend to focus on that happy path of the quick start where you want to get the developer up and running as quickly as possible and they use your application in a very specific way. But where the tools I've seen that not been successful is they don't then think about, well, how do I break out of that happy path? How do I become a power user? Can I configure things outside of the recommended way? Or just because I have some custom thing that I need to be able to do. And so we wanted to provide developers with a very easy way just to drop in a couple of lines of code and solve a particular problem. But every developer knows that it's never just a couple of lines of code. You always have to do extra things. And when you need to get into the details of that, that's where a lot of products fail. And so that's why we've got this model of primitives that you can get into the details of. So we've got those key primitives that I mentioned. And potentially by the time this podcast is out, we'll have a new primitive, which is data redaction and personal information detection. And that is actually a really interesting one because it uses entirely, it's executed entirely in the WebAssembly module. There's no API component to that. And there's a reason for that in that we've written a custom parser, so we can do that entirely in WebAssembly. But also, personal information is exactly the thing you don't want to send to a cloud service. And every single other product that I've seen that does this always requires you to send it to their API and then they do the detection, which is great. And that's one way of doing it. But then you have to trust that third party. And the goal that we had with our module was that you could do all the detection and the redaction entirely locally. And we would report the offsets in the string to our dashboard. So you could go back and find where that personal information was, but we would never see any of that data through our API. And that's one of the great things about WebAssembly is we can implement that entirely locally.
What is the parser parsing? Like just random strings that might contain like personal information? Is it like parsing natural language?
I will pass what you give it. So we'll look at the body of a request. You can give it the headers. You can give it any string. It's just an SDK that you import in, and you can use that as a completely independent SDK provided by Arcjet if you like, or you can use it as part of the rule set. And the use case that we're building, the first example use case is a wrapper around LangChain, so that when you're calling a third-party LLM, you're not sending it personal information, and we can detect that before it goes off to the LLM API. So if you have a support form on your website and you've got a chatbot that's powered by AI, you don't want customers sending a credit card number or other personal information, particularly if you're in a regulated environment where you have healthcare information, for instance, or you are not entirely convinced that you've managed to redact all your logs, or you've got some kind of like GDPR compliance where you've got to be able to delete someone's data on request. You just don't want any of that to go through your infrastructure. And so we've got this new component that will process it entirely within your environment and that allows you to detect and optionally redact that.
I guess this would be like some level of like structured data, like credit card numbers, phone numbers, social security numbers, address, maybe. It gets harder when you're like doing names, because that would be, you know, very loose.
Right. This is, yeah, we've had a lot of fun going through all the different formats of data and thinking, well, a name, how do we have to have a database of every single name in the world? And that is quite challenging to even if we could do that, having that database in the SDK would cause it to balloon quite a lot. So yeah, names we don't redact. It's very difficult to detect. That's a perfect use case for an LLM or some kind of a natural language analysis or something like that. And that is one of the things that you would want to then send to an API that does the analysis for you. But we think that the core components of personal information that you want to ensure never appear in your infrastructure, like a credit card, for instance, for PCI compliance, that can be done entirely locally.
Yeah, I think there are definitely levels of severity for the kind of data that you get leaked. Like if you're leaking someone's social security number, which I guess everybody in the US has already had their social security numbers leaked now, so maybe it's a moot point. But it's not something that you want to be leaked from your organization. So, that's something that's like relatively well structured and easy to block. But
Right. It's the leaking is one thing. You obviously that you just don't want that to happen, but it has happened and the data is out there. I think was more challenging for organizations is the privacy compliance where you've got to remove or update personal information. Because if someone submitted something like an email address or some other personal information into your system and it's gone through your API and it's been logged, maybe it's gone to Datadog. So it's in Datadog for 15 days and then it ages out into an S3 bucket and you're retaining that for 2 to 3 years, maybe. Trying to find all that information is almost impossible, and trying to show that it's been removed is very, very challenging. And so the goal there is that never appears in any of your logs. It never appears anywhere in your infrastructure that can't be updated like a database. But doing that log, just redacting fields in logs is not trivial. And so the goal of this is less the leak protection, which it does do, but it's more the can you comply with all the privacy requirements that we now have?
So you mentioned LLMs in there. Have you guys experimented with any interesting ways of using LLMs to do security stuff? Like, do you give it a request and say, "Is this bad?"
We have done some tests and experiments on it to look at the characteristics across multiple requests. The challenge that you have with looking at requests is just the volume of logs and being able to understand them. And this hits the token window limits of LLMs very, very quickly. Like Google's 1 million token window is very, very interesting because that allows us to put in a meaningful amount of data in, but it's not cheap. And so really we're falling back on what used to be called machine learning, is now called AI, but companies like Cloudflare have been doing this for probably over a decade now, where they're actually just doing machine learning on all of the requests that they get. What I think will be more interesting is the kind of instant response or is something weird going on question. And that's often where security incidents start. It's you notice something strange or unusual in your infrastructure or in your activity in your systems. And it's hard to know whether that is a security incident or not. And often you have to engage security incident response teams who are not cheap to go in and actually do the full analysis, the forensics, to understand what's been going on. I think that's where LLMs will become more useful in security, is the post-breach response, the analysis, the forensics, that kind of stuff, looking through huge volumes of data, which just takes a lot of human time to do. And really you want the human specialist knowledge to interpret those results and figure out what you need to do next. But I think the more interesting thing with AI in general and the rise of LLMs is how it's changed how people need to think about infrastructure. Because in the past, you could assume there's a zero marginal cost to the additional user, because you're running your cloud infrastructure, adding a new user into your application, there is an additional cost, but it's so tiny that you wouldn't really notice it for most applications anyway, most SaaS applications. But with AI, there is now a linear relationship between the number of users and the cost of your application, because you add another user and they start using all your AI functionality, and it's going to cost you on the inference or on the OpenAI API credits or whichever provider you're using. And I think people haven't really made that mind shift yet, the mind shift change, because they're still thinking in this world of, well, the infrastructure's there, it doesn't really cost me more. If we add 10,000 more users, then we have to add some more EC2 instances or increase our concurrency limits on Lambda or pay Vercel a little bit more. But with AI, an additional 10,000 users could cost you a lot of money. And so that's why we're seeing quite a lot of demand for particularly the bot detection functionality with AI. People are trying to do inference stealing. And so I think that's the interesting shift that we're starting to notice.
I had one question that I wanted to ask, and you've kind of already spoken to it, but just to sort of iterate on the idea. So Arcjet has a lot of really interesting functionality, and it has described as like the user has a problem. It's usually like a very sort of targeted type of abuse. One challenge with like rate limiting in particular is that if you're doing it in process, if you're doing it as a part of your application, then you could get a denial of service attack, and like rate limiting, which could help you with that, won't necessarily help you if it's like running in process. So I'm curious to hear about how you're thinking about that. I mean, it's sort of obvious that you've made a trade-off for like the developer and like ease of use and like very specific use cases. So it sounds like that's not particularly like something you're trying to solve for, but I'm curious to hear where your thinking is with that, and like if that's factoring into some like future design.
Volumetric DDoS protection is something that we specifically are not trying to solve, because that is provided by all of the platform providers, all of the cloud providers for free. Now, 10 years ago, that wasn't the case. And this is where Cloudflare really made their name. They are the best DDoS protection still in the world. They also have CDN and FreeDNS, which is great. But they made a lot of their money and continue to make a lot of their money on protecting against these sophisticated volumetric DDoS attacks. The differentiation is gradually eroding as all of the platforms add this in. And whilst you'll see the likes of Google and AWS blog about the largest ever DDoS attack that they have mitigated, you'll note that it's AWS talking about it, and they've done it on behalf of their customers, and none of their customers noticed. And that's their goal. They want to provide the infrastructure layer. They're responsible for the security of the network. And just having huge volumes of traffic coming into your network is going to be solved by them. Now, you can pay extra, like AWS has an advanced service where that's when they say, okay, now you need to install our WAF, and you have to set up the rate limits, and you need to ensure that you've architected it in the correct way. You need to be using our global accelerator. You have to use CloudFront. You have to use all these different components. And that starts getting closer and closer to your application. And you have to pay them a reasonable amount of money before they will start helping you with that level of protection. And I think that's where we start to come in, because as soon as you start needing to configure sophisticated rate limits that aren't just blocking a series of IP addresses or ASNs or anything like that, then you're getting into questions around, well, how is the application going to handle that? Which API routes need to have which configuration? And can you just return a generic 503 error? Or do you actually need to return a JSON response with the details of the error, because everybody using that endpoint is expecting to get a JSON response, not an HTML error page that's potentially going to break their application? And so these are the things that we're focused on, is where you need the infrastructure team probably, but you also need the development team. And historically, we've just had developers focus on the application, and then they give it to someone else to deal with the infrastructure, or they're dealing with the DevOps side of things, and there's a separate team for security. But ultimately, security then needs to get developers to make the fixes and to make the changes to the application. And the incentives are different. Developers need to build, security people break, and they try and interface somehow to get those fixes in when they need to. And there's often this tension because developers need to build stuff. They're not incentivized by the security team's incentives. And so that's why we're focused on these things that really need that application context. And we think that over time, the cloud platforms will just deal with all the DDoS attacks, and we can focus on things where you really need that understanding of the application and the context.